All right, welcome back, Marvels. I'm going to go over the first three problems in video review part one, and then the second three problems in video review part two. Number one, this question gives me information about a man with a salary of $30,000 per year with a raise of $2,400. The first question is, how much has he earned after the first 10 years? And the second question is, how long will it take for this person's salary to be greater than $50,000 per year? So when I begin to think about this question, I immediately wanted to make a table to see kind of what the pattern was. So I made this pattern. The first year he's making $30,000. The second year he's making $32,400, and the third year he's making $34,800. If I'm increasing $2,400 each time, that tells me this is an arithmetic sequence because it is increasing by addition. What I did next was figure out how much he was making after 10 years. To do that, I used the general formula for finding any term of an arithmetic sequence. To find a sub 10, I needed to take a sub 1 plus 10 minus 1 times the common difference, and that is an original equation from your note card. I did that math and I got $51,600. So in the 10th year, his salary has increased to $51,600. Now to answer the question, it was how much has he made after 10 years? So after 10 years, I want to find a partial sum. The equation for that is n over 2 times the first term plus the last term we're looking for, and in this case that would be a sub 10, which is why I needed to calculate it there. I plug in the values I know, do some math, and after 10 years, he will have earned a combined $408,000. The question goes on to say, how long will it be until the person's salary is greater than $50,000 per year? So what I did there was set $50,000 equal to the formula for finding any term of a sequence. Because in this case, I already know the output, but I'm searching for the input. Remember, n in either geometric or arithmetic sequence is an input, where a sub n is an output. I was given the output. I do my math carefully and I get 9 1/3 years. Well, we don't pay salaries, or salaries don't change in the course of a year, so it will take 10 years, which matches what we actually calculated at the very beginning, and this problem happened to use 10 both times. So it would take 10 years. Moving on to question number 2. In question number 2 is determining the sums for these sequences. These sequences are not the same. First, this is an infinite sequence because it goes on forever. And the fact that I am all of a sudden seeing some fractions makes me think that's probably geometric. It's also flipping signs, which is another sign that it's a multiplication that's going on here. In part B, I see that it's not infinite, but it's getting very, very small. And again, this looks to me like it's going to be geometric because it looks like there's a multiplication going on in between there. The final one is written in a different notation. This is sigma notation. And I don't see any exponents. Remember that exponents are a key that it's geometric. So without any exponents, it makes me think this one is arithmetic. Let's go ahead and look at my work. For number 2, here's the pattern. And I know that it's infinite. I know that a sub 1 is 18. And based on this, I can tell that the ratio is negative 1/3. To get from 18 to negative 6, multiply times negative 1/3. To get from negative 6 to positive 2, multiply times negative 1/3, and so on. That tells me it's geometric. So to find a sum of an infinite series, I can use this new equation that we learned most recently, which is a sub 1 times 1 over 1 minus r. When I plug in the values I know, a sub 1 is 18, r is negative 1/3, and I work out my math, I can simplify this down to 27 over 2. So this function, or this infinite series, is going to actually converge at 13.5 or 27 over 2. Part B. Part B is a finite because it does not continue on forever, but it's still geometric because the ratio is 1/2. It's also actually converging because the ratio is less than 1. The only thing I don't know is the end term for this final one, even though I don't need to know that, because there are multiple equations that allow me to figure out the sum of the partial sum of a geometric sequence. So here I did an example using the log, and I get that n equals 9, but that's kind of unnecessary to use, because you could jump straight down here and use the formula a sub 1, which I know is 1/3, minus a sub n, the final term, which is 1 over 768, times the ratio, which is 1/2, all divided by 1 minus the ratio. When I plug that into my calculator, I get the decimal approximation 0.665. When I did it the long way, I also got 0.665, which tells me I probably did it correctly. And in the final one, I did a sigma notation, and I broke this up so I could put it into the equation. S sub n equals n over 2 times a1 plus a sub n. The n value is 60 because that's the last input. The first input was 1. In order to calculate a sub 1, I plugged 1 into this simple rule. So 3 times 1 was 3, minus 2 is 1. That tells me a sub 1 is 1. A sub 60, I had to do a little bit more math. To find a sub 60, it was 180 minus 2, which is 178. Once I knew those two terms, I could plug them into this formula, and I get 30 times 179, which is 5,370. Lastly, number 3. Number 3 on this review says to just simply write this in sigma notation. That isn't very difficult. The only thing I need to do is figure out what is the rule here. So just looking at it, 5, 9, 13, it tells me it's going up by 4. So if the rule is 4x, in order to get a first term of 5, it's going to have to be 4x plus 1. In order to get a second term of 9, that would be 2 times 4, 8, plus 1 would make me 9. That is matching, and so I'm pretty confident that that's the rule. I wrote my rule, 4x plus 1, to the right of the sigma sign. Under the sigma, I define that x equals 1 because my first term is 5. And I have to do a little bit of mental math to figure out what the last term is. But if I do this in reverse, what number times 4 plus 1 equals 37? Well, if I take that 1 away, I'll be looking for 36. 4 times some number equals 36. That number is 9. So 4 times 9 plus 1 is 37, which means you need to add up all of the terms of the series, starting with the first input, ending with the 9th input, and adding them together. This is the correct answer in sigma notation.